get out of the way so you don't have to mess with it. So 10.2, we're going to add and subtract, multiply matrices when possible, and write a matrix equation equivalent to a system of equations. And I'm looking at so we've worked with matrices before. We've worked with them when we were trying to find a solution to a system of equations. So we kind of already know a little bit about matrices, but a matrices has a dimension, and the dimension always is talking about the rows by the columns. So when they say this matrices is a 2x3, it's because it has 2 rows and it has 3 columns, which it just says in that sentence right before it. And in my mind, for the longest time, I got this confused. I was like, how will I ever remember what these numbers represent? And I would even have to guess and check in my calculator, but I finally was like, okay, you're going to sit down and remember this. So the way that I remember it is I always go, you have to go down first and then over. And that forces me to count. Okay, that's 1, 2. So that's where we get our 2 would be the front. If you go down first and then 1, 2, 3 columns represents the 3. That helps me to kind of remember what goes with what. We do have a way of kind of categorizing items in a matrices. So like this, if I were to talk about, well, what is this right here? This A23. Well, that's saying that number, it's an A variable, whatever is there, is located in the 2nd row and the 3rd column. It's just a way of describing where something is in a matrices. So if I wanted to say, well, what is in the place of A31, then I would go, oh, I need to go down 1, 2, 3 and over 1. So it would be this place, A31, because this is 3 rows, 1 column. That's all that is. Okay. So when you add or subtract matrices, all you really need to remember is they have to be exactly the same size. So if you're looking at a matrices that's not exactly the same size, they would both have to be 2x3s or 3x4s. You can't do it. You can't add them and subtract them unless they're exactly the same size. When you're multiplying them, the rule is a little bit different. They do not have to be the same size. In fact, sometimes when they are the same size, that's a problem. Because when you're multiplying them, you can only multiply them when the number of columns in the first matrix is equal to the number of rows in the 2nd matrix. So that's a little bit confusing. So let me give you a visual of that. So if I'm talking about 2 matrices, and let's say I say this is matrix A, this is matrix B. If I want to multiply a matrix that is a 2x3 and I'm multiplying it, I'm going to put a dot for multiplication so it's not confused with this times right here. And I say I want to multiply it by something that is a 3x4. That is doable because the columns and the rows are the same. Those are what you're looking for that match. So if I do it in that order, I'm good. If it's a 2x3 times a 3x4, these 2 numbers are the same, the columns and the rows, then that one, this is going to work. So we're good with this one. If I switch these, and let's say this time I want to do a 3x2, or even if let's do this. Let's just switch the A and the B. Let's say I want to do a 3x4 and I want to multiply it by a 2x3 and I'm doing it in that order. Well, the answer is going to be no, because whatever is here has to match whatever is here. This is going to be a giant no. You can't multiply them unless these 2 things in the middle are the same. Does that make sense? At least understanding you're going to get an error on your calculator if you don't do, if that happens. So you want to make sure that you're at, and it does matter, the order matters. Whereas like before, if I was saying just with regular numbers, 2 times 3 is 6 and 3 times 2 is 6, can't do that with matrices. A times B is not the same as B, matrix B times A. They're not the same. Okay, because see how that we would be able to do one, we can't do the other. It's just different. And your calculator is going to give you a big red mismatch error or something. You're going to know that it won't work. So you do not have to write down all the steps to type in the matrices and how to work this, because they're written for you on this page. So please just relax and don't worry about having to write all that down. These are pretty good directions. So let's go straight to the problems. It says for the month of June, Maggie budgets $320 for food, $140 for clothes, and $80 for entertainment. It says write a 1x3 matrix B that represents the amount budgeted for each item. So this is what matrix B would look like. A matrices is just a fancy, I guess, a fancy way for organizing data. And so it kind of looks like a table in a lot of ways. So if I wanted to organize this, the first thing I would say is, okay, we're really talking about June, the June budget. And they want 3 columns for the June budget. That would include the 320, the 140, and the 80. The 320 is for what she budgeted for food. The 140 is what she budgeted for clothes. And the 80 is what she budgeted for entertainment. I'm just going to say ENT. So looks like a table, right? This is one of the simplest ones we could do. Now, businesses use these things, this kind of organizing things, especially in like an Excel document, a lot, because they're making estimates about a lot of things, not just one person's budget. They're having to do a lot. So that's one of the applications that we actually use a lot in math and computer programming. So after receiving a raise, Maggie increases the amount budgeted for each item in July by 5%. So, and wants us to write a new matrix R that represents the new amounts after they've been increased by 5%. So this is going to be her July budget. When we get done with it, it's still going to be for food and clothes and entertainment. And so the easiest way to get we could also do this using the matrices, but I'm going to go ahead and do this here, and I'll show you in just a minute how we can get those numbers. But if I multiply by 1, that will give me back my $320 I had already. And I want a 5% increase, so I also want to multiply by 0.05. This kind of saves you from having to do 2 steps if I want a 5% increase. Most people are going to say 320 times 5%, they get the increase and they add it back on. And that's fine if you want to do the 2 steps. But if you multiply by 1.05, you're going to be able to handle it all in 1 step. So 140 times 1.05, I'm just taking each of these numbers. 80 times 1.05. And that's going to get us our new matrix that we were supposed to have for her July budget. So 336. $147. And 84. Okay. And this next question says, what's going to happen whenever we add those two matrices together? So we say B plus R. So what do we actually end up when we say, well, adding those two matrices together? What information is that going to give us? One of them is the June budget, one of them is the July budget, right? So, I mean, common sense, I think, is just that if I add those together, that's going to tell me what her June and July kind of combined. If I add them together, budget. And it would be really simple to just do this by hand. But when you get something more complicated, it's not just 1 by 3. It would be harder to do this by hand. So we're going to go to our graphing calculator and make sure that we're able to add B plus R to get this new matrices. So I am going to, like I said, these directions were written down for you on the page before, so don't get stressed out about trying to write everything down. First thing I want to do is get my matrix to pull up. So I'm going to call matrix B A. So I'm going to do second, and matrix is right there at that X -1 on the first row. X raised to the -1, or X inverse is what you would call it. And there's the word matrix written right above it. So I'm going to pull that up. Now, these are in alphabetical order, so I'm not going to call these B and R. I'm going to call them A and B. I'm just going to have to remember where I put them, right? So I'm going to go second matrix, and I want to put something in A. So I'm going to arrow over to edit, and then I'm going to hit enter. And this matrix is a 1 by 3, and I'm just typing in 320. This is what we were calling matrix B, her June budget, 140 and 80. Then I'm going to get out of that. So I did second matrix, and I went over to edit, typed all this in. I'm going to get out of that by doing second quit. Then I'm going to go second X -1 again. And this time I want to get matrix B typed in, which they call it R. Okay. And this part is a little bit confusing because a lot of people want to go down to B and hit enter, but that's not what you need to do. We want to edit matrix B. So we want to go over to edit, then down to B. I have people that they can't figure out what they've done wrong multiple times, and what they keep doing is typing over matrix A. They keep going over to edit, and then because what they'll do is they'll go down to B and then over to edit. And what happens when you go down to B and over to edit, this moves back up to A. So you need to go over to edit, then down to B. Then hit enter. And we still want a 1 by 3. This is going to be her July budget when we got to add the 5% increase. So 336, 147, and 84. Okay. Typed in the June budget, typed in the July budget. I'm going to get out of here, second quit. And now I want to show you two things. One thing I want to show you is, do you remember we took all those matrix, the first June budget, we multiplied them by 1.05? So I could have done just 1.05 times, so second matrix, and hit enter because it's in matrix A, and it would have given me those numbers 336, 147, and 84, right? We could have just multiplied it by, this is called a scalar. If you want to multiply a matrix by a number, then you can do that. So the other thing we wanted to do was second matrix, we're going to add matrix A plus matrix B. I'm going to arrow down to B, hit enter, and it's going to tell me that those new numbers, this would be her June and July budget, is 656. And once again, this would have been really easy to do by hand because we would just be adding the budgets in those categories. See, it's 656, 287, and 164. But when you're working with a very big corporation or something, There are a lot of applications where this would save a lot of time. Okay. Even if she was going to be doing this for the whole year, that might help her to be able to put it in some kind of Excel document where she could get them to add all the way up. Waterworks Incorporate manufactures 3 types of kayaks and its 2 plants. The table below lists the number of each style produced at each plant in April. So this number 90 represents the number of ocean kayaks that were produced at Greensburg plant in April. They want us to write a 2x3 matrix that represents the information in the table. So it's frustrating because this is just a matrix. Is a fancy table. So if I want to write a 2x3 matrix, I'm just basically describing what is in this table that's already there. I am going to use initials just to save us a little bit of time. So this is Madison plant, Greensburg plant, the whitewater kayak, the ocean kayak, the crossover kayak, but it's the same numbers, 150, 120, 100. We're just not using a table, we're using a matrix. So it's just asking us to write a matrix with this data in it. It says that the manufacturer increased the production by 20% in May. So find the matrix M that represents the increased production figures. Okay, so this time I do think I'm going to use what we said before, and I'm going to say, okay, let's find out what's going to happen for May. I'm going to go ahead and label everything so it's kind of ready to go. But all I'm doing that's going to be different is that I'm increasing my production by 20%. So to do that, I'm going to want to multiply by 1 to get back what we had already in April. And then I want to multiply by 0.20 to get back an extra 20%. So I'm going to right now put this one in my calculator as matrix A. Okay, and it's going to give me the answers to this when I do 1.20 times matrix A. So I'm going to go to my graphing calculator and go to that first column. And I'm going to push that X -1. So second X -1, and I need to edit matrix A. So I'm going to hit enter. This is a 2x3. One thing that's nice about this is you really don't have to remember that forever because it's going to change to whatever it is. So if you got it wrong and you accidentally put a 3x2, you're going to go, well, that's not what it looks like. And you're going to know you need to fix it and switch them. Just typing in the values we had on our table. Okay, I'm getting out of that. I'm going to type in 1.20 so that I can get the extra production that they're going to have in that next month. I think it's May. So it's 1.20 times, so second matrix, and I do want matrix A. I'm going to hit enter, and it's going to tell me my new numbers that this would be for the production that we're going to need for that next month. We're going to go back and say, well, the Madison plant needs to make 180 whitewater kayaks in May to meet their increased production that they need. This asks me, well, tell me what happens when you add these two together. Well, now we've got April and May production. We're still talking about same type of kayaks, and we're still talking about the same plants, but this is going to tell us what our combined production for April and May is. And once again, you could just add them together. If you were just going to add them together, you would add the 180 plus the 150, the ones that are in the same place, 120 and 144. Some of you may have an easier time at that, and that's fine if you do that. So I'm going now to type in matrix B, second. Nope, sorry. Yeah, that was right. Second, x negative 1. And I always want to go down first here, but you're supposed to go over and then down to B and hit enter. And this is a 2 by 3. Now we're typing in the new numbers of, well, now we need 180, 144, 120, 216, 108, and 156. After you get it typed in, you're going to say second quit, and we want to add those two together. So second matrix A plus second matrix B. It's going to tell me what my new numbers are, the 330, 264, 220, 396, 198, 286. That's it. Okay, so this last problem says that we've got one slice of cheese pizza. It contains 290 calories, 15 grams of protein, 9 grams of fat, and 39 grams of carbs. So they're wanting us to write 1x4 matrices for pizza, gelatin, and milk. I'm not gonna make you label each one of these, but the pizza would be 1x4. I'm gonna call it in my calculator A, but they're calling it P. 290, that's the calories, 15 for the grams of protein, 9 for the grams of fat, and 39 for the grams of carbs. And so I'm gonna just label them once at the top instead of you having to label them every single time. So this is the protein, and they are in grams. It is important that on the next one, we start writing down the information about the gelatin, that you at least have it in the right order. In other words, you want calories, protein, fat, carbs. So they are in the right order. So 70 calories, 2 grams of protein, 0 grams of fat, 17 grams of carbs. And matrix C, which is going to be our milk, 150 calories, 8 grams of protein, 8 grams of fat, and 11 grams of carbs. Okay, so there's 3 matrices that we're going to deal with. The very next question says, well, what happens, or what would you get if you did 3P plus 2G plus 2M? And they're saying, well, what is that even talking about, right? So what that's talking about is if we had, so sorry, here's the milk. 3 pieces of pizza, right? 3P would be eating 3 pieces of pizza. 2G would be having 2 gelatins and drinking 2 cups of milk. So when we do that, what we're going to get is a matrices that is describing the number of calories in grams, protein in grams, the fat in grams and the carbs in grams. And this is only going to be, which is a little bit surprising, that this is only going to be a 1x4 matrices, because it's got, we're basically adding all of these matrices up that are the same size after we multiply them by something. So this is 3 pieces of pizza, 2, I'm just going to say gelatins, and 2 milks. This is how many calories, protein, fat, carbs if we do this. So what we would want to do is go type this stuff in, label them for each matrices. So second matrix, we want to edit matrix A. This is going to be a 1x4 now. And we got 290. This is first one is representing what we have for the pizza. Get out of that one. Second matrix again, and we would go over to edit before you go down to B. Still a 1x4. Typing in the information about the gelatin. Then I'm going to go to second matrix, and I'm going to go over to edit, then down to C. It looks like that one's already in there for me, 158, 8, and 11. So I can get out of that. Then I just do the multiplication. So 3, second matrix. I know I'm going fast, but I am going to go post this video. I'm trying to get to the review. So if you need to go back and look at the video of how to do this, you can do that. So second matrix, B. We had, so this is our 3 pieces of pizza, our 2 gelatins, and we need 2 milks. And that was C. I'll hit enter, and it's going to tell us that's the number of calories we would have eaten, that 1310, 65 grams of protein, 43, is that the, what was that? What's that category? Yeah. And then we got 173 carbs. So that person should be almost done eating for the day, right? Which is kind of scary if I compare that to what I eat, because I could probably down that easily in one meal. Hate to admit that. But 3 pieces of pizza, we're barely getting started, right? No, I'm just joking. I mean, maybe at one sitting. I could have another 3 pieces of pizza for lunch if I ate 3 pieces of pizza for breakfast. So that's what that is. This says that 2 of the items sold at Sweet Treats Bakery are gluten-free bagels and gluten-free donuts. The table below lists the number of dozens. This is important. So this right here is 25 dozen of each product that are sold at the bakery's 3 stores in 1 week. So it says the bakery's profit on 1 dozen bagels is $5 and 1 dozen donuts is $6. So I'm not going to go to the calculator and put all of this in. So basically what we're doing, so this is the Main Street store, the Avon Road store, the Dalton Avenue store. We've got bagels, and we've got donuts, and they want to know what the profit is going to be for each of these. So if we want to make a matrices of what the profit is going to be, and you absolutely could type these in the calculator and get that way, but sometimes it's just easier to just do this. So bagels are going to give us $5 of profit a piece. So we would take 25 times 5. And 25 times 5 is 125. Then we do 30 times 5 to get the profit for the bagels at the Avon store, however you want to say that. That's going to be $150. At the Dalton Avenue store, 20 times 5 is going to give us 100. For the donuts, we get $6 profit. And so we've got 40 times 6. That's going to give us 240. 35 times 6. $210 profit, and 15 times 6, which is going to give us $90 profit. So once again, you could have taken those and put them in as two different matrix, multiply the top by 5 and the bottom by 6, and have gotten that. But it says use matrices to find the total profit on these items at each store for the given week. So we just did it by hand. There's nothing wrong with doing that by hand. Okay. So that is the end of 10.2.